what are the things are available in the Midas Gen. So based on that, we will see how we can do in the Midas Gen. So first of all, before started, so I wanted to explain you the most important thing is about the GUI. So you have to be familiar with the GUI. If you are aware about all the commands and what are the symbols are there, so that it is easy for you to understand how to model in the Midas Gen by using the efficient way. Okay, the first thing is about the tree menu. So whenever if you see, I just open my this one file, open project. I just open my one file. And I can open the one existing, sorry, I will just say file and new project. Okay, now file new project means what happened. So if you see the something, everything is blank. The bottom is the message window, so that whatever the things you are doing or something is wrong, you can highlight it from the message window. Similarly, the tree menu is the most important, because the menu means what are the things are available. Table, what are the things if you are doing something node also. If you double click here, you can see here entire thing, it is come into the Excel sheet, means X, Y, Z coordinate. If you want, you can type it here and you can directly get the your nodes in the your plan. So means here no need to work only into the your GUI. You can work with the Excel also as well as in the table also. So it's depending upon the URL, or else you can use the text editor also. We have the text editor for the working purpose. So it's up to you how you wanted to proceed. Similarly, grouping, you can do the grouping and the works. Most important is the works. Always you have to click on the works menu. Means what happened, the works menu means the year, what are the things you are doing, you can see in the works menu. Something if you miss, something if you there, it will show you into the works menu. Means whenever you are defining something, it will automatically highlight it in the works menu. So it will come one step at the bottom. So once we start, you can understand. Similarly, the second thing is here, this box, this rectangular box, this is for the node elements. So in this box, what happened, if any particular node, if you are facing some error, so you can directly type the node number and just enter. The program will highlight or select that particular node. So this is for the node numbering, and the second one is for the element numbering. So this is for the element, something is the element you wanted to select it, or something is already selected, you can see from the here. So in this way you can understand these two things, what is the important of these two things. And second one is about the this one display option, and display and the display option, these two options you can go through the view. Display, first option is display and the below is display option. Display means what happened, this is for the if particular thing like nodes, if you wanted to see the node numbering, so this is into the node. Something related with the element, then you can go to the element, and in the element you can see the local axis, wall ID, element number. If you wanted to see something about the properties, then go to the properties and you have to say material number or name. So whatever the name you are defining, based on that you can see the naming on the screen, you can see. So this is for the display purpose. Same way for the loading, view, design. So depending upon the type, the sub option will select it. You have to select it based on that. Now the next thing is display option. In the display you can see the next option is display option. Display option is used for the background purpose. Means what happen, right now first is option is font means if you wanted to change the font, even the display size or something, that you can change it from the font. Second is color. Now right now my background is the white or else black, so you can select from here, or else if you want a multicolor you can select it from this box, and then you have to say apply, then program will apply for the background. Similarly here, material as well as the section. If you see element, in the element wise you can change the color. Similarly section wise or material wise or property wise also you can change the color of the your particular sections. So these options are available, it's up to you how you wanted to use these options. Next is about the draw. Draw is the most important, because here we have this option draw as a global color. Global color means what happened, the for all the section the color will be the same. Second is the element type color. So depending upon the element type, like beam, like a wall, like a plate, so each and every element type the color is different. If you say material color, so based on the your grade of concrete or grade of steel, it will give the different colors. And the section and the thickness color means based on the your properties, means the section property, it will give the different colors. So this four option is most important. That is, these options are available in the display option. Now we'll start for the one normal modeling, which is the normal geometry. So how we can proceed is, first is we have the various options. First is file import. We can import from the AutoCAD DXF, similarly from SAP, from STAT, or from the tab. So from these files you can directly import. Generally most of the consultants they are using the AutoCAD DXF. You can directly import the AutoCAD DXF file, so no need to model it entire thing. The beam you can the only here for the import function we require the center line diagram. So you can directly import it from the AutoCAD DXF and by layer wise, and you can assign the property based on the layer. So this will help you, or this will minimize your timing. Second thing is, in the view, sorry, in the structure, we have this option grids. You can define the point grid or the line grid. So once you define the grids, so based on that you can generate it, your model. So this is the second method. So in this way also you can do. And the last method is about the nodes and element, means you can directly start with the node. So where you want the column points, over there first you start with the nodes. So I will show you about how we can use the nodes and element option. So I just come to this option, nodes and element, say create node, or else you can right click on screen also. The whatever the before run analysis, right click means it is the model oriented, and after run analysis right click is for the result oriented. So I just say right click nodes, I just say create node coordinate 000. So I just say apply. Now here you can see I just select, this is for the selection purpose. I just select this one, and now here the one point is selected. So this is the first option. The best option means it's depending upon the geometry, means it's depending upon the person to person also. If you see the some of the consultant, they are much familiar and easy with the AutoCAD DXF, because they know how to generate the center line plan. So based on that they will generate. But some of the consultant, they don't wanted to believe on the AutoCAD DXF, because some if the joint in between the two line, if it is the nearby or if it is the duplicate, then it will give the error. So it's depend the person to person how they have their methodology. So you have to be careful if your draftsmen are good, or else if you are the if you know how to generate the proper the center line plan, center line for the import function, then you can use AutoCAD DXF. It is the easiest method actually, AutoCAD DXF, but you have to be careful for the joints between the two lines, or beam column joints or these things. Now I will generate this one. Now based on the one point, I can generate the other node. How I can generate? I just select this node, right click, nodes, and just say translate. Translate means what happen here, we have this option copy and move. You can copy also, you can move also. It's depending upon the your geometry, means you wanted to move it or you wanted to copy. So in this way. Now in the copy, I just say my X is 4 meter, 4 times. Say apply. Now if I say this one, now you can see here my 4 nodes are generated. If you wanted to know the numbering, you can go to this display option, say node number. Okay, now you can see the node numbering. If you select something, see this is the third number, row number is selected. The same thing, it is highlighted, node number. Okay, if you select fourth one, this one is coming. If you select the first one, 134 is selected. So you can see from the here, and if you scroll it over there, then program will tell you the number of selected node is equal to 3. Okay, I just stop this one. Now I come to the next method is about into Y direction. Again I select all. If I do not select something, then I just right click node, and if I say translate, now this is the equal distance, but I want into the unequal distance, then what? Then you have to click on the unequal distance Y, and then you have to give the distance. Just say 4 meter first. Second is my 6 meter, and the third is my 4 meter. Means what happened? First point to second point distance is 4 meter. Second point to third meter my distance is 6 meter, and the third to fourth point is 4 meter. So in this way you can define the your distance, that is unequal distance in the y direction. If I say apply, what the error it will come? Error is no selected node. So message window will guide you if something is wrong into the something you're doing wrong. So you have to just say select all. I just say apply. Now you can see my all the nodes are generated. Now this is my column nodes. If I wanted to modify it, come to the tree menu. I just save this file. Okay. And one more thing is, once you save the file, we have one option, that is the auto save feature in the tools preference. If you see here, auto save, it is the 5 minutes. You can change it anytime, and so that the program will automatically save your file in the background. No need, and it will not ask you it will not pop up you also. It will directly save your file. And once you save the file, then also you can perform the undo and the redo function. But don't close the file. After opening and before closing, whatever you are doing, you can redo and undo it. But once you close the file, you cannot undo it the anything. Now the next thing is, if you come to the tree menu works, you can see the nodes. If you double click, the program will select the all the nodes. Now the next thing is, if I wanted to modify this one, then by the display also you can do. Otherwise, come to the tree menu, right click, and just say right click on the nodes option, say table. Now one table is generated. This table you can copy to the Excel, do the modification again back, or else you can change it here itself. If you see here, if you right click, the whatever the commands we are having in the Excel sheet, those commands are available. Find, copy, copy all, paste. Here the paste option, sorting dialog. You can shortlist it also. So these are the things are available. You can do anytime. Now I wanted to generate the properties. Means that right now I am looking for the my the still sorry RCC structure. So for the RCC structure, just come to the first option, properties. Even you can right click here, properties, and just say material. Then also it will work, or else property and material property. Now material property. First thing is add. You can add the new property based on the code. You can add, means if I say add, it will ask the type of design. So based on the type of design, it is going for the design purpose. If you say concrete, then it will use only for the concrete design. If you say steel, then it is for the steel structure. And the SRC, that is for the concrete, steel reinforced concrete, that is the composite section. So these are the nomenclatures we have. Don't use the user defined. Generally user defined we are using only for the analysis purpose, not for the design purpose. If you wanted to perform if you wanted to design it, then you have to use the steel, concrete, and SRC. Now I will use concrete. The based on the concrete, here it will ask the standard. So it might be you are using the Indian code, so it will not ask you the so many codes. It will ask you the IS and the BS. So I just say IS code. So based on the IS code in the database, it will ask the so many M10 to M80 grade. Okay, if RCC column and the steel roof, then which design to be selected? You have to select it both the things. Means it is the not a code actually. It is for the material actually. So if you are using the concrete, so those element you are selected for the concrete, then it is going for the concrete design, and those element you are selected for the steel type of design is the steel, then it is going for the steel design. That is only the difference actually. It is not for the designing purpose, means whole structure will design only for the concrete, whole structure for the steel. It is for the material actually. So based on the material, that element is going for the design. not the entire structure. So you have to perform the steel as well as the concrete, both the design. Now I will select any M25 grade, and for the ISRC M25 you can see the modulus of elasticity, that is the 5000 root FCK. The value will come up to 25,000 to 5, yeah, 25,000 Newton per mm square, but it is value is kilonewton per meter square. You can convert it, or if you want you can change the unit and see the value. Then Poisson ratio, thermal coefficient, wet density, entire thing is calculated by the program as per your standard code. But if you wanted to modify this data, you can come to the standard and you have to say none. None means what happens, this data you can modify. It's up to you. So this option is also available. Say apply. If you say apply, then command will continue. You can see in the tree menu that material grade is added. Similarly, if I say M30, I just say M30, say OK. Now M30 is also added. You can see in the tree menu 25, 30, but that is coming into the blue color. Blue color means what happened, that property you are defining but still you have not used anywhere. So it will guide you that which are the properties you define and which are the properties you assign into your structures. Now next is modify. Modify means what happened, the existing material is there, you wanted to modify it, then you can use the modify. Delete, for the deleting the property. Next is the copy. Copy means the same property you can copy into the next this one, and the something name or something you wanted to change it, then you can change it. For this reason you can use copy. Now last option is import. Import is the most important option, because in the import what happens, if right now you are doing you are using the Midas products, okay, the Midas Gen. So if you already done the 3-4 projects, okay, so next time onwards no need to import or no need to define the properties the newly. You can import it from the your existing Midas Gen file. You have to just go to the import and just give the extension, means the Midas Gen extension from the previous folder. If you click over there, then it will ask you the which type of the property you wanted to import. Based on that it will import the property. So these two options are available for the import, add, copy. So these numbers are available. This is for only for the material. It will copy only the material grade. It will not copy the section or else thickness. So for each and every element, every properties you have to import it from the n number of file. You can import the n number of data, and it is not mandatory that all the values or all the section will come here. You have to select it which section you want to import. If you want only the one section from the 10 sections, you can select only one section will come here. It is not coming the entire sections. Or if you want all, then you can import all also. So it's depend upon you. Now I come to the sections, add. Now in the section, if you see section data, here we have the various options: angle, channel, I section, section, box, pipe. So based on that your section shape, you have to select it. If I select the angle, see, this is the L angle. Now it will ask the user or DB. DB means database. From the steel table, it will select the property or section. So from the which database? So you have to select here and come here and you have to select IS. If you see IS, so based on that in the bottom you can see ISA, all the sections are available. So based on that section, if you click anywhere, so it will taken care of all the section properties. Okay. And similarly, if you want to modify this value, then click on the user and you can modify the properties. So these two options are available. Otherwise, for the RCC, we are just click add. I just give the property B 230 by 450. My section shape is solid rectangle. Say user. This one is 0.45, 0.230. If I say apply, command will continue. That is other area 600. Say apply. Now for the column, see 450. sorry, 300 by 600. 600 apply. Here one more thing I wanted to notice is no need to define the material grade. At the time of modeling the member, you have to define your material grade. Okay, right now no need to define any material grades. Now H 300 by 600 is done. Now next is properties 300 by 450, 450. Okay, so now these things are done. Similarly, in the sections, we have the various option value. You can put your own value IXX, IYY. Otherwise, you can import from the AutoCAD DXF. Facility is also available. Similarly, SRC. SRC means steel reinforced concrete. Now you can see the periphery concrete and in between the steel sections are available. So these things are also available. Otherwise, you can click here and just say rectangular beam I beam. So periphery rectangular I beam, in between the I beam is available. So RCC with I beam, this option is also there. Similarly circular with I is also option available. So inbuilt uh, concrete inbuilt steel section, so this option is also available. You can select, you can define the properties, and you can the design. Yes, for the built up section, you have to come to the combine, and in the combine, we have these options: 2I combine shape, I or C combine shape, I or C combine shape 2. So various options are available here in combine section for the steel structures. So maybe this property or this type of the sections can define. We have this option 2I combine shape. So this one, you can see in this one, the top is a C section and the below is the I order. So this type of the sections are available. Yes, 2I section is also available here. 2I section horizontally and vertically. Or if you want the cross, then this one is also available. The I section with a plus mark. So this type of the section is also available. So you can give this type of the sections also. And if you want the together, then you can define in this way. See this one T sections, opposite for gantry column to I section side by side. So here we have this option. So in this option, here you have to change the properties. You can give your only data 1 and data 2, the best that it will calculate. Sorry. Zero point zero 0.03. So in this way you can do it. Otherwise, in the I section here they are asking about the center to center distance. You can change the center to center distance. Means it is not mandatory that we have to give only the center to center distance. And if something is there, then you can use these options also. I will show you. Tools, we have this option section property calculator. In the section property calculator, if any irregular sections are there, you can define it here itself. Means I will show you. Section, create a sections. You can create the section. It is the kind of the one, the draw option. Here you can define your own sections, and then you can check whether it is passing or not. So this option is also available to generate the properties, to generate the sections. Okay, and even one more option is available in this, means you can what you can say, you can import from the AutoCAD DXF also. Means if you see the file import AutoCAD DXF, if you know the section, the odd panel or any panel of the section, you can import from the AutoCAD DXF. So these two options are available. Otherwise you can model it here and you can do it, otherwise you can do in this way. So in this way you can define. Similarly, the properties, next option is in the section property is thickness. Again, thickness you can define import also, or if I say add, you can define in plane and out of the plane thickness. That is for the shear wall as well as the slab also. Because here no need to model the membrane slab, you can directly assign the loading to the connecting beams. Or else if you wanted to model the slab, then it is as a finite element you can model and you can take the design. So these two various operators are available here. Right now I am giving you the 230 thickness for the shear wall. I just say okay, close. Now you can see here in the tray menu M25, M30 plus beam sizes are done, plus thickness sizes are done. For a slab, you have to click on the plan and the out of the plan. Both the thickness you have to define the same thickness, because the we are the working on the that assumption that the plane section remain plane before and after bending. So means that the for the RCC section, the member in plane and out of the plane, both the ways our thickness are same. So you have to define the same thickness. Okay, and for the shear wall also it is the same, but sometime if you wanted to design only for the out of plane, if you do not want to do for the in plane movement, then you can do it the two thing. Don't put the value in plane, just put the value in out of the plane. For that reason this option is available, but for the design purpose we are not doing in this way. Our the shear wall, it is coming the in plane and out of the plane movements, as well as the slab also it is coming the in plane and out of the plane movement, because of the at the end we have the support conditions. So because of that reason the both the places the in plane and out of the plane movements will come. Now I select the entire structures, this one, and I come to, I wanted to generate the column. Just right click elements and you have to say extrude. Just say extrude. Extrude means what happen? Here we are having option node to line element. Means from the node it will generate the line. So line, maybe it is vertical, maybe it is horizontal, maybe it is in the X direction, maybe it is in the Y direction, maybe it is in the Z direction. Those that thing you have to define it. So I will define here as a beam M25, sorry, M30 grade. My column size is 300 by 600. Beta angle, if you want, you can define. And now here I will say my 3 meter height, say apply. Now you can see my all column is generated. So based on that it will generate the column. Now I wanted to generate the beams. So for the beam generation, just come to this option, right click element and just say create element, and in the create element first is the general type. You can see truss, tension only and hook cable, compression only and gap, general beam and tapered beam, plate, plane stress, plane strain, axis symmetrical, solid and the wall. If you say truss element means it will only take the axial forces, it will release the movement. Similarly, the based on the your element type, it will go for the analysis. So you have to choose based on the your that the means how you wanted to the take the reaction, means that particular behavior of the elements. So you have to select it. Now I will say a general beams, that is for the normal this one, M25 grade 230 by 450 because of the plane beam. I just click here and I'm just click first point and the last point, first point and the last point. Then what happens if you see program will automatically break the element each and every joint, because we are having this option intersect nodes and element, so that no need to click on each and every node. First click, right click, whatever the nodes are in between coming, it will automatically break. If it is not break, then there is a nodes intersection between beam and the column. Now, once I did these things, what about the other direction? So I will select these beams on a 3D view, right click, element, and I just say translate. And in translate, I just say copy, equal distance. I can click first point and the last point from the layout or else from the your main plan view, and then number of times 3, and if I say apply, it will change. But if you see in the y direction, my this one is 4 meter, the next one is 6 meter, and the again third one is my 4 meter. So you have to use the unequal distance in y direction 4 comma 6 comma 4. You can directly type, select the beam, and then here we have these two options, copy node attributes. This what happened if you wanted to copy the support condition, nodal load or something. If you want, you can copy, otherwise you do, if you do not want, then no need to copy. Similarly for the copy elements also we have this one option, beam and releases, the beam loading, pressure loading, various options are available. Based on that you wanted to copy or not. I will say apply. Now you can see everywhere it is generated. Same thing, I just select this one and just say equal distance 4 0, and this is 4 time, say apply. Now you can see entire frame structure is generated. Now one more thing is, whenever if you see the frame structure, so everything is flush from the top, but right now it is entire thing from the center to center because we are modeling from center to center. But at the time of the designing or at the time of the analysis, we required from the face of the member. So my top beam should be a flush at the top of the column. So you have to come to this option structure, just say structure type, and in structure type you have to click on this option convert sulfide into the masses. This is for the conversion of sulfide, which is the you already model it, so it will go for the seismic calculation, and then click on the top of the beam section and top of the slab. If you say okay, now I zoom it here. Now you can see everywhere the top is flush. So most important, you have to click on this option. Without that you cannot proceed, otherwise you face there is a difference will come in the calculation of the movement, because we wanted to calculate the movement from the face of the member. For that reason this option is required. Now next thing is I come to the properties, boundary. I can define the boundary, but I will define the boundary later on. Before that I will tell you the what are the things are available. First is define support. You can define the support condition. Point spring, this is for the pile spring. If you know the pile spring values, you can directly put the values on a spring support, means that is the stiffness values. Second is surface spring. Surface spring, these values are used for the subgrade models, means if you model the raft, you can directly apply the K value and you can directly get the design as well as the soil pressure diagram and the entire thing. Next is pile spring support. This option is also available, means inclined pile support, because of the lateral soil, it will resist some the stiffness, so that modulus values also you can define. So this option is also available, pile spring support. Similarly elastic, general links, these options are available for the base isolator, dashboard. So for this reason, similarly beam and releases, this option is available. Beam and offset option is available. Plate and release option is available, means if you do not wanted to pass the movement into the main beam or for the secondary beams, you wanted to release it, so you can use this option. Then you have to click on the panel zone effect. This is for the calculation of the movement from the face of the member, that we already click on the structure type also. Then come to the loading. Now before defining the support condition, I will just apply the loading to the all member, and then I will copy and directly show you the results. Now I come to the static loads. So in the static load cases, so we have to first define the which are the load cases we are defining. So I just say SW, that is for the self weight. My type is dead load, say add. Similarly, SIDL, that is the superimposed dead load that I define into the floor finish or something. Then LL, that is the live load. Type is live load. Add. Similarly, EQX, earthquake X. Type is earthquake. Add. And the Y, earthquake. Add. Here it is, we are defining only the name of the load cases. We are not defining the any coefficient, that we have to define it later on. Say wind X. I just say wind load on structure. Add. And the Y, add. Now these seven cases are defining. If I closed it, you can see into the your tree menu, all the seven cases are there. But in that in between there is a nothing. Means still we are not defining anything in between of the load cases. We are just defining the name of the load cases. Now first thing is in the static load cases, structure, load and the masses. Here first option is self-weight. Means the program should calculate the self-weight, but in which load cases. So we have to define it here as W. My Z is -1 because of the gravity direction, and 100% I wanted to calculate the self-weight into this load case. If I say add, then program will calculate the self-weight in the self-weight of the structure on this SW case. Now second is the load to masses. This option is used for the calculation of the seismic weight. Generally for the seismic weight, we are considering the self-weight dead load is 100%, SIDL is 100%, and the live load which is 25% or the 50% depending upon your live load value. Right now I am considering only the 25%. So whatever the my total weight is there, the based on that it will multiply and it will take the seismic weight. Now you can see here my load to masses are done, my self-weight is done. Now next is about the loading. Now for the loading, I will just select this property 230 by 450 all over. Right now I am all over, I am defining the same the my property. Just say element in the beam loading, just say element, say replace, and SIDL, say here I will say my -10 and apply. So everywhere my load will apply. How we can identify? Just come to the tree menu. Now in the SIDL case, you can see element beam loading. Right click and just say display. You can see the values. Similarly, we have this option in the element, that is uniform load, concentrated force, concentrated movement, uniform loads, uniform movement, trapezoidal loads, trapezoidal movement, and uniform pressure, trapezoidal pressure. So these are the options are available. Based on that, you can apply the loading. If any inclined members are there, then don't click on the global Z direction, click on the local Z direction. So based on the your local axis, it will apply the values. Means if my truss element is there, so my Z local axis Z is inclined. So based on that, my load will apply also inclined. So this option you can use. Now next thing is about the slab loading. Before that slab loading, we have the three method, most important methods. One is the pressure load. Means if you model the plate element, you can directly assign the loading, and that is as per the finite element analysis. Second is hydrostatic pressure. Hydrostatic pressure is used for the triangular loading on the vertical walls. Means the retaining wall soil loads you can define, or else water load also you can define. So that is under the condition under the hydrostatic pressure. And assigned plane load means if you do not want to model what we can say dummy line, and you wanted to apply any the gravity loads or uniform load on a slab, so this option is useful. Now I wanted to apply the slab loading, that is the one-way two-way loading. So we have to use this option, assign floor loads. Just click here. I just say define floor load type. So you have to first generate the grouping. Means I just say S1, and my self weight of the slab is say 100 mm. So I will say -2.5. SIDL is -1.5, and my live load is -2. Add. So this is one group. Similarly, S2, my slab weight is increase. say 325. Rest of the things are same, say add. So in this way you can add the property, and self-head of the slab we have to define because we are not modeling the slab, membrane slab. So we have to define the self-head of the slab. Otherwise, if you model the slab, then no need to define the self-head because the program will automatically calculate. Now I wanted to assign the values. So now I will just show you. Come to the assign floor loads. Say S1, say two-way. And what I will do is I just select this first property, first point, second point, sorry, first point, second point, third, fourth, and this one is last. If I closed it, here you can see loading. The program will automatically take care of loading. Now here it is coming the all over the triangular loading. Why it is coming the triangular? Because it is the square panel 4 by 4. So my loading will be the same. Now if I change it to the another portion, say S2, this one. Now you can see here my longer span it will take the triangular loading, shorter span it will take the triangular loading. So this option is available. And again, if you want the one-way loading, you can click here one way, and the which direction you can just click here first point, last, this one and this one. Program will automatically define the one-way, two-way loading. So this type of the options are available. So you wanted to know more about the loading or it is okay? You just drop me the message so that I will understand that for the loading it is okay or not. Yeah, for the cantilever is you have to model the slab actually because that cantilever it is connected with your the backside of beam. So you have to model the slab based on the FEM analysis, and it will take the all the movements and entire thing into the current beam. Otherwise, you can directly apply the loading to the connecting areas. So this option is also available. Any other things? Okay, so can I start for the next part? Okay, thank you, sir. So now in this way you can define the loading. Now the next part is about the copy of this floor into the another floors. So what I will do is I just select all. You can see here we have this option, select all. I just select all, come to the structure, control data, and I say building generation. I just say 6 floor or else say 5 floor and 3 meter, say add, and if I say apply, you can see the program will generate the my floors. Okay, in this way my entire building is generated. Similarly, all floors, if I right click here in the tree menu and if I say display, you can see everywhere my loading and entire thing it is completed. Both the places entire thing is done. My loading plus beam loading, my slab loading, entire thing is done. Now next is we have to define the support at the bottom. So just right click on screen and just say boundaries, say support. And now for the support we have to select the point. So for the selection of the point you can do one thing, you can come to the this option front elevation and select the bottom nodes and just say D all, that is the translation, R all, that is the rotation, and apply and just close. Now you can see here display all the supports are fixed. Okay, this icon hexagonal means it is for the 6 places. 6 means it is for the 3 for the rotation and 3 for the translation. If something if you missed it, then it will turns to the black color one part. Similarly, one part it will turn to the black. Now next thing is loading, lateral loading. Before going for the lateral loading, still we have not defining the diaphragm actually. So for the diaphragm, you have to come to the structure, control data, and you have to say story. Now in the story, program will ask you first is the auto generate story data. I just click here and then program will automatically take care of Z axis. First is 0, 3, 6, 9, 12, 15 and 19, 18. Because of the 3 meter height difference, it will automatically count this one, and the below is for the seismic accidental eccentricity. It will take the 5% of plant dimension, and for the wind it will take the 15% of plant dimension. If I say okay, here it will program will generate. Now if you can see here the consider means what happen, the program will consider the rigid diaphragm. If it is say do not consider, then it is the semi-rigid diaphragm. So these two differences are there. If you model the flat slab, then there is the semi-rigid diaphragm, then program will automatically identify. Right now we are not modeling any slab, then it is considering the rigid diaphragm. These options are available. Now I come to the next method about the loading. Come to the loads. We have to click on the lateral, say wind load. Now in the wind load, just say add. So in add, load case name Windex, wind load code. We have to select IS 875. Sorry, 875. So it will ask the standard method or gust factor method. For the gust factor method, again you have to give the value, gust factor value. Then basic wind speed, here you can define. Right now I am considering the 39. Say terrain category 2, class B, drag coefficient is 0.01. Building design K1, you can consider the general building is 1. Temporary share it will change. So based on that, it will the options are available. Otherwise, if you want, just say user define and put your own value. Now I wanted to calculate the wind in X direction. So I just say wind in X direction, and for Y it is 0. Okay, the normally when we go for RCC slab, then shall we have to define the rigid or semi-rigid? If you model the slab, RCC slab means that is the as per the finite element, or there is a no frame structure, means there is a no beams column to column connected. There is a flat slab. Then you have to consider semi-rigid diaphragm, because over there that slab is taking the some stiffness. So for that reason we have to consider the semi-rigid diaphragm, and over there each and every nodes are deformed individually. So for that reason no need to consider the point rigid diaphragm because of semi-rigid. Yes, for the flat slab you have to consider semi-rigid, and for the beam column junction means for the membrane analysis you have to consider the rigid diaphragm, because each and every column is connected to the beam, and because of the beam entire structure is move in one directions. Now I will say wind is in the one direction. Now I come to the wind load profile. If I click on the wind load profile, you can see a story force, story shear, overturning moment. Each and every floor you can see the pressure, loaded height, loaded breadth, wind force and story shear and overturning moment. Entire thing it is available here. If you wanted to know how the pressure is calculated, just click on the wind load calculation sheet. So here in the background you can see the wind load is F is equal to P into area plus F dash. How the P is calculated? CP windward, that is the windward minus leeward into PZ. PZ is calculated based on the zero point 0.6 into VZ square, and the VZ is calculated based on the VB equal into K1, K2, K3. So based on that it will calculate, and if you go down each and every floor what are the values are there, you can directly get it. So these options are available. And if I say okay, one is generated. If I say again add, or else wind Y at 75, 39, 2B, 0.1, this one, x is 0, y is 1, then you can see the values. If you click on the x, there is no value, y there is a value, just say OK. Now my x and y is generated. Now I come to the seismic load, say add. Now in the seismic load I just say earthquake x, say seismic load code 1893-2002, say soil type 4, say medium, zone is 4, this one is medium, importance factor 1, damping 5. Now again the period calculator. The again period calculator based on the 1893 we have three formula. One is for steel, one is for and two for RCC. Again for the RCC we have one with infill and without infill. So if I click on the period calculator, the program will ask you based on the your code formula. You can see 0.075 without brick infill panel and with brick infill panel. So these two options are available. You have to choose it. Based on that it will calculate the your time period. I just select this one formula, then R factor is 3, then X is 1, Y is 0, and now accidental eccentricity, the positive negative option is available. If you want, you can choose it. Right now, I am not considering the positive negative eccentricity, so both the places is 0. Inherent eccentricity, if you want, you can consider. Now, seismic load profile, you can see the profile. This is for the story force, story shear and overturning moment. Now in the story shear, you can see the value, what is the seismic weight values and the seismic force values and the story force and story shear. If I wanted to know about the calculation, just click on the make seismic load profile. In this profile, you can see if I came down here, what are the things I am applying? This one, time period in X and Y direction, my R value, and what is my AH value. So SA by G, Z by 2, I by R, my AH value that is come into the point 1, and my the seismic weight 17971 with 25% of live load and 100% of gravity load. If I multiply these two value, you can get the value 1797.1. You can see here it is divided by 100 your point 0.1. You can directly get 1797, and if you came down each and every floor you can get the values. So you can get entire thing by using these formulas. For if I say apply, my command will continue. Just say wind earthquake Y, just say 0, here it is 1, and rest of the things are same. Okay, close. So in this way my earthquake and these things are done. Now if I want I can change it, this one, my 1 2 3 4 and 5. Now my in the 5 level I wanted to change the column, sorry, beam sizes. Now you can see here it is 230 by 450. I will come to the my tree menu. I just said 230 by 600 and drag it to the screen. Okay, just pick and drag to the screen. You can see my property will change. So my this all the above beam sizes are 230 by this one. If I select these two beams, I just say 300 by 450. It is done. And if you click on the structure, control data and story, you have to update the story because of the stiffness, that again CG will change. So you have to click here, just say auto generate story data. Okay, close, close. Program will calculate the entire diaphragm and your entire thing. Second thing is, if I come to here in the tree menu, in the tree menu you can identify my earthquake X. Just right click here and say display. You can see the point. See here in the center point, it will apply the your lateral load in the earthquake X, earthquake Y, wind X, and wind Y. So these options are available. Similarly, in the loading, we have the dynamic load option. You can define the spectrum analysis also. And again, temperature and pressure is available. So these things are available, moving load, heat of hydration, construction stages for the analysis. And then I come to the analysis, we have this option, P delta buckling analysis, eigenvalue, that is the dynamic. I just click here, just say 10 modulation. Okay. So dynamic analysis are there, heat of hydration, moving load. So these are the options are available. Now I just run this file, say perform analysis. Now you can see how much the time it will take. Within a 1 minute, the my program is run. Okay. Now I come to the results. First is it will ask for the load combination. I just say load combination, say concrete design, and just click on the auto generation. Based on the auto generation concrete, it will ask the design code. I just say IS 456-2000, and if I say OK, the program will generate my 25 load cases as well as my serviceability load cases, which is defined in IS 456 table 17. So based on that, it will calculate the my entire serviceability as well as the strength load combination. If you want the worst combination, that is the envelope, then go to the general and just say auto generate, and here we have this option add envelope. The program will generate the envelope for the strength as well as for the serviceability. For the both the things, this option is available. Now I wanted to check the results. Come to the reaction, say reaction force and moment. So based on the combination, if you see FZ and apply, here you can see the diagram. If you want to see the value, just click here and apply, then you can see the value. If you want to see the value in tabular format, just click on this dot dot option next to the reaction force and moment. Just click here. It will ask the which things you want. If you say OK, here program will directly generate the fx, fy, fz, mx, my, mz based on coordinate. If I right click here, I can shortlist, I can change the decimal, and I can directly export to the Excel, or I can generate for the my dynamic report table also. So these direct options are available. Now next thing is about this one, deformation. If I say deform shape, say earthquake X, DX, animation, and apply. Now you can see animation. There is some animation is also available. No, envelope will be generated automatically, but only the thing is envelope is not used for the design purpose, because program itself automatically designed for the worst condition. So it is only for the analysis purpose. Means if you wanted to check my analysis result for the envelope, then program will automatically generate it for the strength as well as for the serviceability. For the both the cases, program will automatically generate. If you click on the load combinations, just say general, say auto generation. Now here you can see add envelope. Sorry for concrete. Based on the IS456 add envelope, the program will automatically generate 25 load cases as well as the envelope. But if you use into the general, means that combination, it is not going for the design purpose. It is only for the analysis purpose. For a footing design, service load is used. So what the program will do for the footing? For the footing also, if we go here, footing design, so here we have to generate the auto generation. So here the program will automatically generate the load combination for both the cases, because the forces will transfer based on the serviceability load combination, but the moments and these things are also available. So based on that, it will give you the area as well as the steel into the design plus, and here you can check for the sizing purpose, but that is based on the BS and the ACI code in Midas Gen. But if you use in the design plus, then it is basically as per the IS 456. Similarly, I wanted to see the forces. Just come to this option, forces, say truss, beam force, beam diagram, which thing. So I just say beam diagram, say any one combination, say my, say values, say all and apply. Now you can see here each and every floor, here it is defined the values. Now I just zoom it. Now you can see the movement is calculated from the face of the member, not from the center to center. If you want in the detail format, just click on the quick view, click on any one option and just change the here load combination and the component, and you can click anywhere in the bottom. You can see location and this is the value. The max minimum values also you can get, as well as the each and every station you can get the values. If you want into the detail format, so you can click on this option, that is the beam element beam detail analysis. If you click on the beam detail analysis and just click the combination, any one combination, and just click on the any one beam, in the background you can see displacement, shear force diagram and bending moment. And red means it is the distance. You can modify the distance and you can click anywhere on a screen, and then also you can see the values. This option is also available. Now forces, wall diagram also you can see. Anything whatever you want you can see. Stresses are also available. So various options are available. Diagram in this way you can see. Now I come to the mode shape. I just click here and just say vibration mode shape. In the vibration mode shape, I can see the various mode shapes. I just say multiple mode and just click on the 6, 7, 8, 9, 10 mode shape. Just say OK. Now in the one window you can see the various shape of the your structure. So this type of the shape you can see. If you click on the animation, you can see the animation also. Now I come to the next option, that is the values, how the values are coming. Now for the values, you have to come to the vibration mode shape, and here next to this vibration mode shape dot option, just click here. Program will automatically open the one option, that is the how much the my period. You can see 0.88, 0.68 or something, and the summation you can see from the here. Summation for the x, my it's coming into the fourth mode shape, that is in the x direction, but for the y it is coming into the 5. So my minimum number of mode shape should be the 5. If I providing the 10, it is okay, but I cannot provide less than the 5 number of mode shape. So I have to design for the at least for the 90% of the mass summation. Now this is one done. Second thing, if you want some values, you can just go to the result table, say story, and in the story you can get the whatever the things you want, story drift, story shear, force ratio. Various options are available. So it's based on the design engineer, what are the things they want. You can just go and click and select the cases or the combination, and they can directly get the values. So this option is available for the calculation of entire thing. Similarly, you can change to the story drift for the, sorry, you can check the weak story also, and torsional irregularity check, various checks are available. Program will automatically identify and tell you whether it is detected or not. So this is about the result orientation. You can check and you can see the results. Now I move to the design part. Before moving to the design part, I just wanted to know whether you want to see something about the result part. See, in the story we have this option story. We have this option stop story and weak story. If I click on the weak story, program will identify, see this is the regular. So here instead of the regular, program will tell you that it is the weak story. Yes, soft story check, weak story check, direct checks are available. If you see story, soft story check, weak story check, torsional irregularity check, weight irregularity check, story shear force ratio, story eccentricity, story shear for response spectrum, story shear for time stay. The both everything is available here. Yes, it will mention, and then you have to increase the earthquake at that particular level. So what you can do is you can directly assign this one load. We have this option load to masses. That particular one floor means the load floor diaphragm masses. You can increase the mass in that particular floor. Otherwise, in the seismic load, you can directly assign the value at the any floor. X, Y, and the Z in the moment means what are the things you want, you can directly assign. You have to do it. It is only tell you that whether it is the detected or not. If it is detected, then you have to increase the above floors into the 2.5 times. Program will not automatically do it. Okay. Any other things? We have to put the sorry. Shall we have to put the column at that location? No need to put the column at that location. You can directly assign. What about the floating column? Shall we have to put the column at the location and that change any support condition? Floating columns. Yeah. See, generally what happen if the floating column is started from the your gird or from the beam. So in that level, you have to directly model it actually, and that particular beam you have to divide it because of the point load, but no need to define any support condition. Okay, and over there also no need to define the diaphragm, because if you define the diaphragm then it will consider as a rigid diaphragm. Over there you have to consider the semi-rigid diaphragm, so that the program will take care of that movement and it will give the values. No need to define the means any support type of the condition over there. The program will automatically provide the these values. Any other things? Okay. So we will continue about these things. The second thing is about in the design is, first of all, general design parameter, you have to click on the definition of the frame. In the definition of the frame, you have to click whether it is the program should calculate the effective length factor or you wanted to define it. So generally we said to program to calculate the effective length factor. The program will automatically calculate. Just click here and just say OK. Then general design parameter, we have the live load reduction factor is available. Similarly, the member assignment, it is the most important, because what happens, this is the kind of the finite element package. So each and every beam it is divided at each point, but my column to column beam, if it is divided into the 2 3 parts though, so design will go for the each and every part, but I want to design for the full length. So you have to go to the member assignment. What you have to do is you have to click on the automatic all and apply. So what the program will does, program will consider the column to column as a one beam, though it is divided into the two parts, then also it will design as a single element for the total effective length. So you can use this option for the double height column also, and for secondary beam. Because of that reason my main beam is divided. For that reason also you can use. Similarly, we have this option unbranched length factor, effective length factor. So these two options are available. Generally it is used for the steel structure. You can define your own values. Yes, you have to release it. That's why I already mentioned you in the boundary. We have this option beam and releases. So secondary beam, you have to release it. You have to release it for the movement into the major axis and the minor axis. Both the direction you have to release it so that it will not transfer the movement to the main beam. Otherwise, negative movement will transfer over there, and unnecessarily you are increasing the movement in the main beam. Here MY and the MZ you have to release it. You can see MY and MZ. And because here that Z is up and Y is the other direction, so you have to relate into the MY and the MZ. MY is the major axis here for the beam, so you have to release it for the MY. Okay. Yeah, come to the design. Now next is general design parameters. Sometimes what happen if because of the inclined beam you wanted to design as a the truss element, or maybe a truss element you model but you wanted to design as a beam element, then you can use this option like this one, the modify the member type. So if you model it, then also you can change it anytime. So this option is also available. Now next is I have to select the code here, say 456 2000, and then I have to come to the RC design. First is the design code. Now in the design code 456 2000, whether you wanted to apply the 13920 or not. So you have to click on this option. If you click on this option, then you have to first design the beam, then you have to design column, because if the beam is not passed in the designing, then it will not go for the design purpose, means not going for the column design, because it is the capacity based design. So you have to first pass all your beam, then go for the column design. I just say here, even you have to click on the torsion design whether you wanted to do it or not. Now next thing is modify concrete material. Material means what happened, the previously we are defining the FC value. If you want for the change to for the design purpose, you can change it, otherwise you can use the same thing. And rebar you have to define it, that is the rebar I am saying that as per the IS, it is I am considering the 500, and for sub rebar, that is for the secondary beam, I will use the FE415. Say modify, for this one also the same thing, IS say 500 and 415, say modify and close. Now my steel rebar is also defined. Now I come to the RC design. Next is the limiting maximum rebar ratio, means you can resist the percentage for the column and the wall also, and the truss also element, means you want 4%, 3%, 2%. If it is going up, then it will automatically say fail. Maximum limiting maximum minimum section size, means here based on the your VR code, we have the limiting size minimum minimum size also. Program will check for that. If you do not want, then you have to hide these options. Design criteria of rebar. In this option, you have to define the which type of the rebar you wanted to use it for the design, and even you have to define the cover also, because still we are not defining about the cover. So I just say main rebar for a beam. I wanted to the 12 mm and the 10 mm, not the 25 mm. And then my cover is should be the 0.025. I just 35. That is from the center of the bar. Then for the column design, I want the 12 and the 16 mm, say 4, and my spiral I will say 8 mm. For the stirrups also I will say here 8 mm, and similarly for the brace, for the shear wall, for each and every we have to define it. Now in the RC design, once we done these things, again we have this option, same beam rebar at joint. So at the joint continuity effect, it will consider the same rebar. Movement redistribution factor, if you wanted to redistribution factor, because as a old person they are using they release 30% and they consider the 70%. Main a beam will transfer the moment to the connecting beams. Serviceability parameter is there. You can define the L by 250, L by 350 criteria. Modify beam, rebar data, column, brace, and the wall. This is for the, you can define your own rebar and then you can check whether it is passing or not. So this option is also available. And then this one is option available, that is the concrete core design. This is for the design of the member. Means if you wanted to design the member, so you have to click on those options. So right now I will select the only the two beams, and just come to the RC design. I just select this one. Yeah, this four. Say this one. Say RC design, concrete core design, say beam design. Based on the your combination, it will take time. Now, right now you can see only the one beam it is selected because it is the based on the property, and right now we are finding only one property. I just say member. Now here you can see this one, four members are there because letting the four beams. If you see 2 by 600, this is the SCK FY value. This is the start, mid, end. This is the load combination, negative moment, AST. Right now it is as per meter square. If you change the unit, say mm here, then now you can see the value, it is in the square. Similarly, 5 of 5 10 means my two layer bar is required. First is fiber and second is the fiber, and then middle it is the 212. So based on that, it will give you the number of bars as well as the area also. It's depending on how you wanted to define it. Bottom 10. Similarly, load combination in this way, ASV and the stirrups. Now if I click here and if I graphic, now graphically it will tell you section diagram, bending moment capacity for the positive moment, negative moment, and the shear capacity. So each and every section it will tell you. But what about calculation? So you have to just click on this option, just say detail based on the your start and end location. I will just go down. Here you can see maximum rebar my values is 0.04 into B into D. Minimum is 0.85 B upon Fy. Whether it is passing or not, it will say okay or not. If the members are fail, it will show into the red color. You need to go and select all the time this detail diagram. For each and every calculation, it will show the formula. Now for the shear, you can see VU equal to VU upon BD. So V equal to what? Entire thing it is mentioned here. So based on that, it will calculate it, the values. Same for the column, so it will show the in detail calculation and this way. And if you want to see in the display form, you can just right click on just say design, say concrete design result. In the concrete design result, if you say the reinforcement, say rebar, say beam, main rebar. If I say apply, now you can see on the screen for the top and the bottom, start, mid, end, entire thing, the values are mentioned. That is the P10, what the number of bars are required. If you want the area, you just click here and the area. You can see change the unit to the mm. You can see the in AST. So based on that, you can define. Similarly, if you want shear enforcement, just click on the shear, just apply. Now you can see the shear enforcement area. Based on that, you can define. And if you want the rebar, just click the rebar and just say apply. Now you can see the rebar. So it's up to you how you wanted to see the results. So these are the things available, and the based on that, for the beam, column, the shear wall, you can see the design. So in this way, you can directly get the design by using this one. And for the footing design, RC design, we have this option footing design. So based on the ACI and the BS code, you can directly get the size of the sections. Means just click on the node number. I just click the bottom node. Here I have to define my material, say rebar, my cover, say bar, say 12 mm, allowable pressure, I just say 250, isolated foundation or the pile foundation, because you can get the number of bars, number of pile as well as the pile cap design. State load combination, just say load combination, footing design, auto generation, program will generate the combination for the footing, this one. If you see the load combination, entire load combinations are there. You can see factor load combination, serviceability load combination. If I came here, you can see serviceability load combinations are selected. Then I come to the change column size. You can change the column size. Reaction forces, based on the your combination, you can see the reaction forces and the movement. Option ACI 31802 or else BS. So both the codes are available to check for the column footing sizes. Ly by Lx equal to means it will give the square footings or else rectangular than of these options. Then axial force and the moment or axial force only that you have to select it. And this is for the self weight. The program will calculate. Say okay. Just say auto design and just minimize this. In the back side you can see 2.4 by 2.9 into zero point 0.5. In the Midas Gen you cannot get as per the IS code, but for the in the Design Plus it is as per the IS code. That is also the latest code, and the Design Plus it is the link with the Midas Gen. So you have to link with the means what are the forces are coming here, the same forces it will directly transfer into the Design Plus. No need to go and manually do it. Over there you can get the drawing also as well as the quantity also. Per meter cube you can get the quantity, steel quantity you can get. So these options are available, and here you can get the exact sizes you can directly get. And if you model it here directly, the raft and the flat slab, then you can directly get the design as per the finite element analysis. So this option is also available here. So these are the things are available in the Midas Gen. Actually, so many things are there, but in the short time we cannot explain you the so many things. So this is about the normal RCC. Same way you can model the steel structure. Only the thing is design part is different, but the rest of the parts are same. Yes, it is possible in the Midas Gen itself. Here you can see design, RC design, the below is the mesh design. So in the mesh design, you can directly design your flat slab and the raft also, as well as your, you can check the punching for the two-way and the one-way, and similarly, you can check for the serviceabilities also. Any other things you want to know in the Midas Gen? Okay, I will share you this video so that you can something is there, then you can identify. And for the still, I will talk with Mr. Prakash for the next lecture or something, so that we can again for the next lecture we can do. Or else you can just first practice it, so that what are the problem you are facing, the same problem we can discuss, and again we can see the what the things we can do, and then we can start for the next session. Okay, thank you so much. Thank you for attending the lectures, and I will share you the link with you, and Mr. Prakash will send you the link. And whatever the problem you are facing, you can mail us on the tech support at the midasIT.com. Myself, Abhishek. So you can directly contact me, or you can directly mail us, so that whatever the problem you are facing, we will discuss through the mail also. No issue with this. Only the thing is you have to attach your drawing, sorry, you have to attach your Midas model as well as the some screenshot, means what are the problem you are facing, so that I will explain you in a brief. Okay, thank you so much. Thank you so much, sir. Bye bye.